In this problem, a balloon is made of a material of surface tension S and its inflation outlet from where gas is filled in it a small area A. It is filled with a gas of density rho and takes a spherical shape of radius r. When the gas is allowed to flow freely out of it, its radius r changes from capital R to 0 in time t. If the speed v of gas coming out of the balloon depends on r as r power a and t proportional to s power alpha, a power beta, rho power gamma and r power rho, then the alpha, beta, gamma, those values we have to calculate. So here a balloon is there. A balloon is having small opening. That opening area is A. From this air is coming out fastly with speed V. The material of the balloon is surface tension S and the radius is R. So first we have to calculate the relation between the velocity and R power A. So this is the general condition. So this R value maximum capital R and finally it becomes 0 when all the gas goes out. So what we know is why gas is coming out with some velocity. There is no law, according to the law of conservation of energy, energy neither be created nor be destroyed. So some kind of energy will be there in the beginning, that is pressure, because of air filled in the balloon. The pressure energy must be there. That pressure energy is coming out as kinetic energy. So pressure of energy inside the balloon is equal to kinetic energy of gas coming out, right? So what is the pressure energy formula? Surface tension by radius of the balloon is equal to kinetic energy of mv square. So proportionality they asked, proportional to, that's why half is a constant. We eliminate all the constants and the mass of the gas is also constant and surface tension of the material also constant. So what we left with? V square proportional to 1 by R. These are all constants. So then V proportional to 1 by root R. That means V proportional to R power minus half. So from this calculation, R power A they have given. So A is equal to, therefore A is equal to minus half. So we got the one answer. A is equal to half. This is step 1. Step 2, let us come to step 2. See, it is fully filled with air. This balloon fully filled with air. This is A. Surface tension S. The maximum radius of the balloon is capital R. Velocity, air speed is V. So I am conditioning initial conditions. In initial condition, that means small r is equal to capital R. Same formula we will use and calculate the velocity value. So here pressure energy is equal to kinetic energy. Pressure energy. pressure energy S by R is equal to half m v square. Mass of the gas not given, density of the gas given. So if density of the gas given, S by R is equal to half density into volume into V square. See how it came. Density is equal to mass per volume. Mass is equal to density into volume. So in the place of mass I have written density. So here in the problem proportionality they are representing. So constants we eliminate. Half is a constant. Now the balloon is having maximum value, so that volume, maximum volume, so volume also have taken as a constant. Then I got S by R proportional to rho V square. From this I can calculate V square proportional to S by rho R. That implies V proportional to root of S by rho R. So this is the value of V. This is an answer. So whatever the steps he is mentioned in the problem, first they have mentioned speed of gas coming out of the balloon depends on R. R value, it is spherical. We have to take the balloon shape spherical, and small r value changes from capital R to 0. So when it is at capital R, general condition we discussed, from that the small a value came. Now when it is fully filled, that condition I have taken, this is the maximum velocity when it is fully filled with the A. Now this is the second step. Third step. In third step, what they are mentioning? They are mentioning in the problem capital T proportional to. What is capital T? See, what is capital T? When gas is allowed to flow freely out of it, its radius r changes from capital R to 0 in time t. Capital R in the t. So from capital R to 0, it takes a time t. So all the gas went out in time t. So how much gas is coming out from this one? Mass of the gas coming out by given time, maximum time, because it is fully filled. Radius is capital R, like that we have taken. This is equal to, see, when the balloon is fully filled, the air applies some force on this small opening, right? So that force, see, this force of gas coming out by velocity. This formula we know. This is the mass of gas coming out from the small opening in capital T time. So what is the force formula? Air is a fluid. So fluid formula A rho V square by V. So we cancel V and V. Now we are not caring for force and velocity, we are caring for this time. So let us take the time. Mass of air coming out of the small opening is proportional to, I will take a proportional to A rho V. Right. So here mass of the gas not given. So what we did, When mass of the gas not given, in the place of mass, rho and volume V we have taken. I will take is equal to only. Why? Because there is no constants V. Right. So I will take the equation here. M by T is equal to A rho V. This M I will write as mass is density into volume by T is equal to A rho V. Here in these terms, volume of the balloon not given, but radius of the balloon capital R given, maximum. See, we are calculating B and C, we are calculating on maximum filling of air. That means small is R is equal to capital R. So here I will write the formula for volume. In the problem they have given the shape of the balloon is spherical. So rho 4 by 3 pi r cube by T is equal to A rho V. These things I am not worried. Why? Because these physical quantities are given in the problem. R cube also given, rho is also given, T is also given. But 4 by 3 pi is a constant. So this constant I will remove. Then what happens whenever constants we omit? This rho r cube by T, constants I remove proportional to A rho V. So now I want T only. Capital T is equal to rho r cube by A rho V. But V value I know. V value I know. What is the V value? I may give some equations. This is the V value. So this V value I substitute here. Rho r cube by A rho, right? In the place of V I will write root of rho r by S. Is it not? Why? Because V is down. So I will write in a, I just inverted way I have written. Since from equation 2. Then T is equal to, here T is equal to is not wrongly proportional to Y, because we are taking proportional. So T proportional. Here what happens? T rho cancels. A is there, so it comes upside numerator, A power minus 1. R cube is there, but in the root also are there. Or root R means R power half. So when bases are equal, we have to add the powers. Plus, so R value is over. Then here S is there, S power minus half. Here rho is also there, rho power half. Rho is in denominator. So this is the equation I got. So in the problem they have given this equation. I will write here. Comparing T proportional to A, sorry, they have given S, A, rho, R. So they have given S power alpha, A power beta, rho power gamma, R power rho. That's what they have given. So by comparing these two, Alpha is equal to how much we got in the s power minus half we got. Beta is equal to how much? Beta is for a minus 1. Gamma is equal to, gamma is for rho, that is half, and rho is for r. How much? 3 2s are 6, 7 by 2. So final answer in equation 1 we got a is equal to minus half. So we'll write therefore a is equal to minus half, alpha is equal to minus half, beta is equal to minus 1, gamma is equal to half, rho is equal to 7 by 2. So this is our answer. Which one option is correct here? Let us see. We are having only two options with 7 by 2. Half must, a must be minus 1. So third option is the correct option. But this question is not meant for NEET students. It is a JEE advanced problem. It is very injustice for giving this one. But one small thing is, in examination, if this kind of questions comes, we should not fear and leave it. But by dimensional method and substitution method, we can do it very, it is not so, but the value of a we cannot calculate. In dimensional method, value of a we cannot calculate. But anyhow, by what you call indirect way, we can calculate this answer, right? That I will show you now. See, t proportional to s power alpha, a power beta, and rho power gamma, r power rho. This is given. So using dimensions, by writing dimensions, let us write dimensions. Time dimension m power 0, L power 0, t power 1 proportional to, here s means surface tension, L t power minus 1, sorry, m t power dimensions of this one, surface tension, s is equal to force per length. So ml t power minus 2 by L. So m t power minus 2 alpha. A means area, L square, whole power beta. Rho means mass per density, mass per volume. So this is gamma. R is the length. This is rho. Like this we can write. So finally, m L naught t power 1 proportional to, see here m power alpha comes and m power gamma comes. After that L power 2 beta minus 3 gamma plus rho, and t power minus 2 alpha. This is the equation we get. So comparing the powers, here t is minus 2 alpha, t is equal to minus 2 alpha. So t is equal to 1, minus 2 alpha is equal to 1, alpha is equal to minus 1 by 2, and from m it is by comparing capital T. By comparing m, alpha plus gamma is equal to 0 by comparing m. So alpha is equal to, alpha came, so gamma is equal to minus alpha, that is equal to 1 by 2. So gamma value is 1 by 2. That's all you can calculate. Third one is 2 beta. This is first equation, this is second equation, third equation. So in first equation alpha you can get, beta you can get, gamma you can get. Third equation 2 beta minus 3 gamma plus rho is equal to 0. This is comparing length. So this by substituting method you check all the values here. Here they have given alpha, beta value and gamma value, rho value. You substitute those values in that equation. If 0 comes, that is the option. Like that, in indirect way, substitution way, you can do it. It takes a little bit less time than this one. Anyhow, this question in Neet is not justified.